Jager. We're going to walk through some review from last year. So this should be pretty easy stuff for you. Pull out your notebook, take notes just as if we were in person. We're going to go through some review of lines. So the first thing to remember about lines is that our slope formula, that's also known as rate of change. We can denote that as the change in y over the change in x, how quickly something is changing over time. Also known as dy dx, which is the same thing as our formula y2 minus y1 over x2 minus x1, rate of change. If we have a horizontal line, that is going to have a slope of 0 because it's staying constant, it's not going up or down. If it's a vertical line, that's a slope of undefined because our change in y over our change in x is undefined. Parallel lines, we know that they have the same slope because they never cross. They're going to keep continuing at the same rate. Perpendicular lines have negative reciprocal slopes. They cross at each other, and so they are negative reciprocals of each other because they cross at that 90-degree angle there. Our equations of lines. We have multiple equations of lines in just different formats. We have our point slope form, which is y minus y1 equals m times x minus x1. And we also have our slope intercept form, the most common form. Point slope form is a little bit easier in calculus because we can just set it up faster. So we will be using that one a lot, but we also need to know our slope intercept form as well. So this first example here says, write an equation for the line passing through the points 2, 3, and 4, 6. We're given a set of points. We need to find the slope. We have a formula here. We can label this as x1, y1, and x2, y2. It doesn't matter which one you set as 1 and 2 as long as you keep them together. So we start with y2 minus y1. So we say 6 minus 3 over 4 minus 2, which is going to be 3 over 2. That's our slope. So now if we want to write the equation, we can just plug it right into our point slope formula here. So we would say y minus our y1 is 3 equals m, 3 over 2, times x minus our x1 is 2. We can plug that right in. So using that point slope formula is a little bit easier with a lot of these problems in calculus. Next, we know a horizontal line, we're just taking that point that it's going through from y because it's crossing the y-axis at that point and it's staying at that point for y. For a vertical line, going straight up and down, we're taking that point at x. It's chopping through the x-axis. So if it asks to find the equation of a vertical line passing through these points, we would just say it's x equals our x point of negative square root 2. Because what it's doing on our axis here is it's finding negative square root of 2 and it's staying vertical through that point. Just to refresh on absolute value means that it makes everything positive. So if we have anything greater than or equal to 0, that's our positive numbers, it's going to just be x, it's going to be that number. Whereas if it's less than 0, we're going to have our negative x because it's going to, that negative actually makes that negative number positive. 2 negatives make a positive. So basically anything you plug into absolute value comes out positive. The absolute value of negative a is a. If we have the absolute value of a times the absolute value of b, that's the same thing as the absolute value of ab because 2 negatives multiply together to make a positive anyways. And then absolute value of a over b would be the same thing as if we had split up those bars. We could do it either way. Our distance formula is just that rearrangement of our Pythagorean theorem. So the square root of x2 minus x1 squared plus y2 minus y1 squared. So this lesson's pretty much just formulas. You need to remember them. So now we get to this question, which is going to break it down into a few different parts for us. It says find the equation for the line through the point P, which we're given here, and perpendicular. So remember, perpendicular means that they're crossing at a 90-degree angle to the line L. And then it wants us to graph them and find the distance from P to L. So our first step is L is in a really funky format. It's actually in standard form. Let's put it into slope-intercept form. So we are going to change this equation. We're going to solve for y to get it into slope-intercept form, or y equals mx plus b. So I'm going to subtract the 2x to the other side of the equation. And we're going to get y equals negative 2x plus 4. So what's the slope of this line? The slope of this line is negative 2. So if we're looking for a line perpendicular to that, that means that the slope of that line needs to have a negative reciprocal. Negative reciprocal means that we flip it and we make it the opposite sign of what it is. So our new slope for the perpendicular line, this sign means perpendicular, we're going to flip it and change the sign of it. So next what we're going to do is we're going to take this new slope and we're going to plug it into our point slope format here. We're going to say y minus y1 equals m times x minus x1. So we're just going to plug in our x1 and our y1 into our formula here. So y1 and x1. A negative negative makes a positive, and we have our equation. So now it's wanting us to find the distance from the point P to the point to line L, which we have right here. So we have two equations here. We could set this one up into slope-intercept format as well. So we can say y equals 1/2 x, or here, we'll leave it right here. So y minus 2 equals, we'll distribute this, 1/2 x plus 1/2 times 2 is just 1. We have our equation here. We can solve this into slope-intercept form as well. So y equals 1/2 x plus 3. So we have this line. This is our line that we created. And we're looking at how far away is this from our line L. So we need to figure out where they're crossing each other so that we can find that distance. Let's go ahead and graph them like it asked us to. So we're going to graph this line. Our y-intercept is 4. Our slope is 2. So we're going to go down 2 over 1, down 2 over 1. We have this line here. We also have this line here. We're going to start at 3. We go up 1 over 2. So we can see that they're crossing each other. We can actually solve exactly to see where they're crossing each other by setting them equal to each other to figure out where they cross. So negative 2x plus 4 equals 1/2 x plus 3. We need to get my x's on the same side to solve for them. Minus 4 to the other side. Negative 2 minus 1/2 would be minus 2 and 1/2 x. This is going to cancel off. This is going to cancel off. 3 minus 4 is negative 1. I can change this into an improper fraction by multiplying. 2 times 2 is 4 plus 1 is 5, negative 1. And then now I can divide by the opposite here to cancel those out. Dividing by negative 5 over 2 and multiplying it to the other side. Negative 2 over 5. And we get 2 over 5. So that's the point at which they're crossing. I can find my y value by plugging it right back into the equation. So I'm going to plug x right back into the equation. 2 over 5 plus 4. So I'm going to get negative 4 over 5 plus 4. I can find a common denominator here. So this would be 20 over 5. So I would get negative 4 plus 20 would be 16 over 5. So that's my x, that's my y. So I now have the points that I can find the distance between. I'm just using my distance formula now. So the square root of x2 is going to be negative 2 minus x1, which we found over here, 2 over 5, squared plus y2 is 2 minus y1, which we had over here, 16 over 5. And I'll let you go ahead and solve that part, and that would be your answer for the distance. Thanks, guys.